In 2006, Pluto's place in history changed forever. For more than 70 years, generations of students learned that our solar system contained 9 planets. Pluto, discovered in 1930, was the small and distant world at the edge of the Sun's domain. Then the International Astronomical Union introduced a new definition of the word planet. Under those rules, Pluto no longer qualified because it had not cleared its orbital neighborhood of other objects. Almost overnight, Pluto became known as a dwarf planet. The decision sparked debate far beyond the scientific community. Many people felt an emotional connection to Pluto, seeing it as an underdog that had been unfairly removed from the planetary family. Yet while the public argued about its title, scientists became increasingly interested in what Pluto actually was. And the more they studied it, the more surprising it became. Everything changed in 2015 when NASA's New Horizons spacecraft flew past Pluto for the first time. Instead of finding an ancient, frozen world covered in impact craters, the mission revealed towering mountains made of water ice, vast plains of frozen nitrogen, deep valleys, and landscapes unlike anything seen elsewhere in the solar system. Among its most remarkable discoveries was a giant heart-shaped region called Tombaugh Regio. One half of this feature, known as Sputnik Planitia, is a smooth basin filled with nitrogen ice. Remarkably, it contains very few impact craters, suggesting that its surface is relatively young by geological standards. This was unexpected. Most small worlds located so far from the Sun were expected to be geologically inactive. Pluto challenged that assumption. Scientists believe slow convection within the thick nitrogen ice may constantly reshape the surface. Over extremely long periods, warmer ice rises while colder ice sinks, gradually renewing the landscape and erasing older impact scars. In recent years, the James Webb Space Telescope has provided an entirely new way of studying Pluto. Unlike visible light telescopes, Webb specializes in infrared observations. Instead of simply photographing distant objects, it analyzes the heat they emit and the chemical fingerprints hidden within reflected sunlight. These observations allow astronomers to identify frozen compounds across Pluto's surface with remarkable precision. Pluto's icy crust contains abundant nitrogen ice, along with methane and carbon monoxide. Under the harsh radiation of space, these simple molecules gradually transform into more complex organic compounds. Over millions of years, sunlight and energetic particles trigger chemical reactions that create reddish materials called tholins. These substances are believed to be responsible for Pluto's distinctive reddish-brown colors. Although tholins are not living material, they are chemically complex and help scientists understand how organic molecules can form naturally throughout the solar system. Pluto's atmosphere is another extraordinary feature. Despite its tiny size and extreme distance from the Sun, Pluto possesses a thin atmosphere composed primarily of nitrogen, with smaller amounts of methane and carbon monoxide. As Pluto follows its highly elliptical orbit, its distance from the Sun changes dramatically over its 248-year journey. During the warmer part of its orbit, sunlight causes surface ice to sublimate, changing directly from solid to gas. This process creates a temporary atmosphere that slowly expands above the frozen landscape. As Pluto moves farther away, much of this atmosphere gradually freezes back onto the surface. New Horizons previously discovered multiple layers of bluish haze extending high above Pluto's surface. James Webb has continued studying these atmospheric components in infrared wavelengths, helping scientists better understand how gases and complex organic particles interact over time. Pluto's largest moon, Charon, adds another layer of mystery. Nearly half the size of Pluto itself, Charon is so massive compared to its parent body that the two objects orbit a point located outside Pluto. In many ways, they behave more like a double world system than a traditional planet and moon. Charon's surface tells its own fascinating story. Enormous canyons stretch across hundreds of kilometers, revealing evidence of ancient geological activity. Its north polar region is covered by a reddish cap created when methane escaping from Pluto becomes trapped on Charon during its long winter. Exposure to ultraviolet radiation gradually transforms this methane into darker organic compounds, painting the polar landscape over millions of years. This continuous exchange of material demonstrates that Pluto and Charon are closely connected, sharing gases, chemistry, and a long evolutionary history. Far from being a frozen relic at the edge of the solar system, Pluto has become one of the most intriguing worlds ever explored. Every new observation reveals another piece of its story, reminding us that even the smallest worlds can hold the biggest surprises. Although Pluto is nearly 6 billion kilometers from the Sun, scientists have discovered evidence suggesting that this distant world may be far more active beneath its frozen surface than anyone once imagined. One of the biggest mysteries is whether Pluto hides a vast ocean deep below its icy crust. At first, the idea seemed unlikely. Pluto is small, receives very little sunlight, and has existed for billions of years. It would seem logical for its interior to have frozen solid long ago. Yet several observations tell a different story. The enormous basin known as Sputnik Planitia may hold one of the strongest clues. This giant depression is filled with thick layers of nitrogen ice and appears to have played an important role in Pluto's orientation over time. Some planetary scientists have proposed that a dense layer of liquid water beneath the crust could help explain how this region influences Pluto's rotation. While this underground ocean has not been directly observed, computer models and geological evidence suggest it remains a realistic possibility. Another fascinating process being investigated is cryovolcanism. Unlike volcanoes on Earth that erupt molten rock, cryovolcanoes release mixtures of water, ice, ammonia, and other frozen materials. In the extremely cold outer solar system, these substances can behave much like lava does on warmer planets. Several large mountains on Pluto have shapes that some researchers interpret as possible cryovolcanoes. If that interpretation is correct, Pluto may have experienced relatively recent geological activity, although scientists are still studying exactly when these events occurred. The search for answers continues through observations from powerful telescopes and improved computer simulations. Pluto's orbit also makes it one of the most unusual objects among the major bodies of our solar system. Rather than following a nearly circular path like the 8 planets, Pluto travels along a highly elongated orbit that is tilted significantly relative to the plane of the solar system. Despite crossing Neptune's orbital distance, Pluto never collides with the giant planet. The two worlds are locked in a stable gravitational resonance, ensuring they remain safely separated throughout their long journeys around the Sun. For decades, astronomers have used Pluto and other distant icy bodies to better understand the structure of the outer solar system. Some researchers have suggested that the unusual orbits of several remote objects could be influenced by an undiscovered planet, often called Planet 9. Although this hypothetical world has attracted considerable interest, no direct evidence of its existence has yet been found. Whether Planet 9 exists or not, Pluto remains an important piece of the puzzle because its orbit preserves valuable information about the solar system's early evolution. Scientists are also investigating the chemistry taking place across Pluto's frozen surface. Radiation from the Sun and energetic particles from space continuously alter simple ices such as methane and nitrogen. Over immense periods, these reactions produce increasingly complex organic molecules known as tholins, giving parts of Pluto their reddish appearance. Although these compounds are not signs of life, they help researchers understand how the building blocks of complex chemistry can form naturally on icy worlds throughout the solar system. Pluto's environment demonstrates that fascinating chemical processes do not require warm temperatures or Earth-like conditions. Instead, even in one of the coldest regions surrounding our Sun, nature continues shaping landscapes and transforming matter in unexpected ways. Future missions may one day return to Pluto with advanced instruments capable of mapping its interior, measuring the thickness of its ice shell, and searching for definitive evidence of a buried ocean. Until then, telescopes such as the James Webb Space Telescope will continue examining Pluto in infrared wavelengths, improving our understanding of its surface composition and atmosphere. Every new observation adds another chapter to Pluto's remarkable story. Once dismissed as a small and insignificant world, Pluto has become one of the most scientifically valuable objects in the outer solar system. It reminds us that size does not determine importance and that some of the greatest discoveries come from places we once overlooked. Perhaps that is Pluto's greatest lesson. Science is constantly evolving. New evidence can overturn old assumptions, transforming a distant point of light into a world filled with geological activity, complex chemistry, and unanswered questions. As technology advances and future explorers push farther into deep space, Pluto will remain a destination of enormous scientific interest, a frozen frontier that continues to surprise us with every new discovery. Its title may have changed, but its ability to inspire curiosity